All right, guys, we're going to continue with our lessons in Unit 1. So today we're going to talk about segments, rays, and parallel figures. So we're going to define all these terms, give ourselves a picture example, and then we'll do some more examples on the back. Okay? So we define a segment as part of a line that's bounded by two distinct endpoints. Okay, in other words, two different points. One starts the segment, one ends the segment, okay? And then there's all the points between those 2 points. So let's draw some lines so we can see what we're talking about. Now I'm going to label 2 points A and B. Okay, so the segment AB is going to be all these points between A and B that are kind of shaded. So we can pull that out and look at it. So that would be our segment. Okay, and as far as naming it, we could say AB with just a line on top. Okay, if you're naming a segment, there's no arrows used. Okay, arrows are only used on a line or array. But for a segment, it's just the bar on top. Or we could say BA. That's it. All right? Now let's define array. So array is also part of a line. Bounded by one endpoint and extending forever in one direction. All right, so we could have let's put our line example back. So I'm going to just pick here. I'm going to start at the point A. And then for array, you have to have another point down the line from it. So for me, I'm going to continue in this right direction, go through B, and then keep going. So if I pull that out to look at this, A is our end point, and B is another point that's down the line. So we would call this array A to B. And for array, you put one arrow on the end. Okay. Notice how I wrote this. You must write the end point first, and then you put the second point afterwards. Okay. If you were to write this, that would mean you're talking about this. Your end point is B and your second point is A. Okay. You cannot reverse the order of the letters and it be the same thing. These are not the same thing. Okay. Hope that makes sense. Now, opposite rays. These are two rays that share an endpoint and they extend in opposite directions. All right, so let's say we start here with this point and we go off this way. put some point down here. Let's call that C, then D. And we have another ray that starts at C, but then it goes this way. And we have E down here. All right, so we would say that the ray CD and CE are opposite rays. Notice because C is the end point, I started both my rays with C. Okay, now you should be picking up something here that two opposite rays form a line, so that's something interesting we can note. You have two opposite rays, they will always make a line. Okay, let's talk about parallel lines for a minute. These are coplanar that do not intersect. Remember, coplanar means they must be in the same plane. So these are two lines that lie in the same plane and they never intersect. So here's the example we're going to draw. We're going to draw ourselves kind of like a box. But it's not really a box, it's a bunch of intersecting planes. Okay, so we got a bunch of planes intersecting here, 6 of them to be exact. Well, and some in the middle, the diagonal planes, but anyway. So if we're going to say two lines that are coplanar, I'm just going to say, let's look at this line right here. Just highlight this one. So like this top edge in front of me. Now, somebody that's parallel to it is that line underneath, okay? They both lie on this front plane, so we can say they're parallel. Okay? Skew lines. Skew lines are non-coplanar. Meaning they're not parallel and they do not intersect. So let's put our box back. Oh, I messed up. Goodness. Okay. So let's start with this top line right here. Now, to get a skew line, he cannot be in the same plane. So it can't come from this top or this front here. So I would say this line on the far corner over here, that's an example of two skew lines because they're not in the same plane. Okay, and then finally we have parallel planes, and these are obviously planes that do not intersect. So if we draw another box, There's lots of examples of parallel planes here, but I mean, just an easy one. You could think of the top plane and then the bottom plane. Those would be parallel planes. All right, let's look at some examples. So, use the figure to the left to answer the following. Name all the segments, and I'm going to adjust this. I'm going to say all the distinct segments. And what I mean by this, I don't want you to list a segment that you can name it another way. Okay, like you don't want to say LP and then PL. That's the same thing. We want to do all those different kinds of segments, okay? So what I do is I just start with one endpoint and I work my way up. So LP, that's a segment. LQ, that's a segment. And then I can jump up to P and make another one between P and Q. Okay, so there's only 3 distinct segments there. All right, let's name all the arrays. So I'm going to adjust this to be distinct. So remember, array, you have to start at a point and then go in either direction. So let's start at L. We could start at L and travel our way through P. Now notice that if I do that, start at L and travel forever through P, I'm eventually going to hit Q. So I would not want to say the line or the array LQ because that is going to be the same thing as array LP. Okay, so let's jump up to P now. If I start at P, I can come backwards to L. That's a different array. So PL. I could start at P and move towards Q forever. I think that's all I can do. Let's jump up to Q. So I can go from Q to P. Or you could have said QL in its place because those are the same thing. All right, a pair of opposite rays. So opposite rays have to share the endpoint. And they have to extend in different directions. So the only one that would work is if we start here at P. So I'm going to say the ray PL. And PQ. All right, that's that example. Now let's look down here at this bunch of intersecting planes. So name all the segments parallel to DC. So if we're parallel to DC, let's find where DC is at. Let's just mark it for us. We have to lie in the same plane as that segment. Okay, so I'm going to start here on the bottom. So if I look in this bottom plane, the segment across from it is going to be AB. Then I can pretend to look on the back side of the box. And I look across that, so I would say HG is parallel. And there's one more hidden in disguise. And it comes from the fact that we can have a diagonal plane. So from DC, I could come up here and make a plane the diagonal plane CDEF, okay? That would mean that EF is also parallel to that segment, okay? Let me erase that because I don't want that there. Sometimes you'll have to do that. You'll have to use those diagonal planes. All right, all the segments that are skewed to DC, I think there should be 4 of them. So skew lines are non-coplanar, so they can't be in the same plane, and they can't intersect. So I would say the first one would be, like, if I start at DC, come around this side, and then look at from A to E. So I would say AE. I would also say BF, because you could come around this right side, and then BF would be skewed to it. I would say HE, because HE is not in the same plane as DH. And then finally, FG. Those are the 4 that are skewed. All right, let's name 2 parallel planes. So it doesn't really matter here which one you pick. I just, for example, you could say the plane HED and GFC. So following those letters, HED, that would be this left side of the box, and then GFC, that's this right side of the box, okay? That's just a pair. There's tons of pairs you can name there. I just picked one out for you. Who is parallel to AEFB? So let's find that. AEFB, that's the front, which means we have to use the back. So I would call it HGCD. All right. Okay, that's all I have. So that's all we have for segments, rays, and parallel figures. This video will be posted for your viewing alongside your homework assignment. Make sure you watch this completely before you do your homework, all right?